So what we're going to be looking at now is cross products. So cross products are another way in which we can multiply vectors. In this video, you're just going to get a physicist's introduction to cross products, where I will only be showing you what you need to be able to do with cross products in order to answer the types of questions that you will be receiving in this course. There is a lot more that you can go and learn about cross products if you want to. So we saw dot products before. Dot products were a way to multiply vectors and end up with a scalar result. With cross products, when we multiply two vectors together, we end up with a vector result. So to symbolize cross products, we use the multiplication sign, x. So the cross product of A and B is written like that. So if we want to take the cross product of a vector A, which is AXI plus AYJ plus AZK, and B, which is BXI plus BYJ plus BZK, then we can calculate it as A cross B is equal to, okay, this is long, but it is on your formula sheet, brackets AYBZ minus BZAY, close brackets, that's in the I direction, plus, open brackets, AZBX minus AXBZ, close brackets, J, so that's the J component, plus, open brackets, AXBY minus AYBX, close brackets, K, so that's the K component. So this is the formula that you can substitute into to get the cross product. Now, if you have learnt about matrices previously, then a slightly easier way to get this formula or to remember this formula is to take the determinant of the matrix that I'm putting up now. If you don't know anything about matrices, then don't worry, just stick with the first method. It works well as well. Now, if you want to work out the magnitude of the vector that you will get when you take the cross products, it is given by the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine theta, where theta is the angle between A and B. Now, this tells us that if A and B are parallel, so there is no angle between them, then the magnitude of the cross product is 0. So whenever we have two parallel vectors and we take their cross products, we end up with 0. Now, if we want to work out the direction of our vector C, which is the cross product of A and B, C is perpendicular to both vectors, to both A and to vector B. So how we can do that is use our right hand rule. If you point your fingers in the direction of the first vector, vector A, and curl them towards vector B, then your thumb points in the direction of the cross product, vector C. Let's have a look at a couple of example problems now, and then I'll give you a few to try before we move on to real physical situations for which we need to use these cross products. Okay, so up the top here, I've written the formula for cross products. Now, with our first question, if A is equal to 1.0i plus 2.0j, and B is equal to 2.0i plus 1.0j, we're asked to find firstly A cross A, and then secondly A cross B. Okay, now possibly you'll realize that because A and A are the same vector, they're parallel, so this has to be equal to 0. If you didn't, then you can substitute into the equation above. So we've got AX is equal to 1, and because the second vector we're also multiplying is A, we've also got BX is equal to 1, and we've got AY is equal to 2, and BY is equal to 2, and AZ, there is no component in the K direction, so this is 0, and BZ is equal to 0. So looking at the equation up the top, anything with a Z component, like BZ here, AZ here, those are all 0. Here we've got an AZ and again a BZ, so this is all 0. So the only part that we're left is this part in the K direction, and when we substitute in, we've got ax times by, so that's 1 times 2, so that's 2 minus ay, which is 2 times bx1, so 2 minus 2k. So mathematically, we get 0 as well. Okay, so part 2, this one won't be 0. We now need to find a cross b. So for a cross b, let's do what we did up here and write out each of these components. So we've got ax, that's the component of a in the I direction, is 1, and bx is equal to 2. We've got ay is equal to 2, and by is equal to 1, and az is equal to 0, bz is equal to 0. So this is nice because we've only got 2 dimensions. So everything, once again, with a bz or an az, which is everything in these I and j vectors here, is equal to 0. So all we need to worry about is this final term here. So we've got a cross b is equal to, okay, ax, that's 1 times by, which is 1, minus ay, which is 2, times bx, which is 2, times k. So this is equal to 1 minus 4, k, which is equal to minus 3k. Now let's just check this with our right hand rule as well. So what I'm going to do here is sketch, here's our I axis, here's our j axis. So let's make A pink. So we've got 1, 2. So this is vector A, and vector B we'll do in blue. So it's 2i and then 1j. So this is vector B here. Now, to practice with your right hand rule, I want you to align the fingers of your right hand with the A vector and now curl them towards the B vector and concentrate on which way your thumb is pointing. Is your thumb pointing into the screen? If it is, then you've done the direction correctly, and that is into the screen is the negative K direction. So that's where the direction comes from. So our next example, if A is 2 kilometers north and B is 3 kilometers northeast, what is the magnitude of A cross B and which direction would it be? Okay, so the magnitude of A cross B is equal to the magnitude of A times the magnitude of B. This times doesn't represent a cross product now, it's just a normal times sine theta, where theta is the angle between them. Let's sketch our little vectors. So here's, we've got north, here we've got east. So vector A is 2.0 kilometers north, and vector B is 3.0 kilometers northeast. So this angle in here is 45 degrees. So working out A cross B, we've got 2 kilometers times 3 kilometers times the sine of the angle between them, which is sine 45. And solving that on the calculator, we end up with 4.2 kilometers squared. Now, the next part is really a bit of a trick question. Which direction would it be? Okay, so use your right hand rule, point it in the direction of the pink one, curl towards the blue one. You can see your thumb points into the screen. So this vector would actually be going down into the ground. So it would be going down into the ground. So north, east, southwest is one plane, and our cross product is perpendicular to this plane. So if our plane is the surface of the earth, then perpendicular to that plane is down into the earth.